Assalamu alaikum. Okay, so today we are going to practice questions from the thermal. But before starting the questions, there are some misconceptions while solving the questions from the past papers because some topics are excluded right now. So the topics like the thermometer, so the questions from the thermometer are not included in new syllabus. And the questions like related to the melting point, the boiling point, to write down the melting point of any type of liquid or the melting point. So they will not ask about this boiling and melting anymore. Plus, they will not ask about heat capacity in new syllabus, but they will ask about specific heat capacity. So that is also not included in new syllabus, that is heat capacity, plus the concept of latent heat. So these type of topics, these types of questions are completely excluded from the syllabus, right? From new syllabus. So in old papers, you will find many questions related to the latent heat and many questions related to the thermometer because these topics are very, very important in the old syllabus. So you will also find many questions in the old papers, but these topics are excluded. So during the questions, when we find this type of uh, topic or question from the past paper, so you may skip that. In this booklet that I shared with you, so I already removed those topics or those questions from the booklet which are excluded, right? So it will be easy for you to find out the questions that are now included in new syllabus. So that's why I removed the thermometer, heat capacity, latent heat questions from this booklet, right? Okay, so today we are going to start with the thermal physics and starting from again the latest paper, the latest questions. Okay, so the first question is the lowest possible temperature is 0 Kelvin. State the name of this lowest possible temperature.
Absolute zero.
Absolute zero, okay. Basically, you all know absolute zero, okay. You all know that when we have to convert the temperature from degrees Celsius to Kelvin, so definitely we have to add 273. Let's suppose we have temperature 40 degrees Celsius. So in Kelvin, we will write 40 plus 273, right? So that will be the value in Kelvin. But when you reach the value 0 Kelvin on the scale of the Kelvin temperature, so that is equals to minus 273 degree Celsius. And this is very extreme, like a cold temperature, we can say. And at this temperature, the vibration or the motion of the particle freezes, and it is almost impossible that any particle or any matter will vibrate or move from its position. So that's why it is called absolute temperature or absolute zero temperature. So this is the concept included in the scale of Kelvin and degree Celsius. And in the next part, okay, in next part, nitrogen boils at 77 Kelvin. Calculate the boiling point of nitrogen on the Celsius scale. Okay, one more thing. Many of us confuse in this idea. Okay, 1 minus 196. That right now, before starting the question, I mentioned boiling and melting is excluded. Basically, in old papers, you know that they ask about like boiling point of any liquid like sodium or molten sodium like that. So they will ask about it. In thermometer also, there are name of the points like this is the extreme highest point, this is the lowest point in thermometer. So these type of topics are excluded. In this question, they use term boiling point, but the main idea in this question is that you know that how to convert Kelvin into degree Celsius. So this is the important thing. They are not asking about like the exact value from the table or anything because they already gives you the value in Kelvin and you have to convert into degree Celsius, right? It is not related to specific boiling point of anything. It is related to the unit conversion from Kelvin to degree Celsius. So we know that 77 Kelvin minus 273 is equals to minus 196 degree Celsius. Okay. In B part, the temperature of a fixed mass of gas at constant volume changes from 300 to 400 Kelvin. State and explain in terms of the particle the effect on the pressure of the gas. So mass is fixed, volume is constant. Okay, so in this question, you can see we have constant volume. Volume same है, and secondly, the temperature is changing. So temperature is variable. State and explain in terms of particle the effect on the pressure. So one answer I got is pressure increases. And also you need to explain how pressure increases. So it is like the example of pressure cooker, right? So what happens in the pressure cooker? Okay, I also got the answer in the chat. Due to more kinetic energy, the particles collide more with one another with the walls of the container. Rate of change of momentum increases, which is the force, and the volume is constant, so pressure increases, right? So basically, this situation is like the pressure cooker because we know that when you seal the container of that pressure cooker, whatever, so volume is now constant and continuously we are providing thermal energy, so temperature is increasing. So definitely collision with the wall increases. And there are some key terms like collision with the wall. This is very important. And the change in momentum. This is very important. This will give you mark. while writing the answer, and also the force on the wall of the container. So these are some important terms that helps you to gain marks easily in this type of question, because you can see it is of 4 marks. So definitely 1 mark you will get for the statement, but other 3 marks you are getting for the explanation. So definitely pressure increases. And I just copy paste this answer over here. So we already discussed all these points in the notes in the class, that how to write for 3 marks or 4 marks in this type of question. Because in this type of question, we know that there is no formula, there is no equation. So sometimes we feel difficult to write for 3 marks or 4 marks if they ask about it. So there are some important terms in this question, just like the collision with the wall or with an other molecules, and rate of change of momentum, the concept of the force. So you can see three important things are there. So that will give you 3 marks easily. Okay. Next part, a sample of gas is at a pressure of 120 kilopascals. The volume of gas is doubled. So volume जो है वो double कर लिया at constant temperature. Temperature is same. Calculate the new pressure of the gas. Okay. So you can see in previous question, they are only asking about the boiling point and temperature increases from this to the new temperature. Now you have to calculate the new pressure. So we know that when we are solving two different pressure, two different volume, so we use the idea of P1 V1 is equals to P2 V2, right? So in this type of idea, we can use this equation from the Boyle's law when we have two pressure, two different pressure or two different volume to compare with each other. But now in this question, you can see only one value of pressure is given, and only the second hint is given that the volume of gas is doubled. So volume is doubled just like the first one. So we have to find the second pressure. So now it is very simple. Let's suppose pressure 1 is given, pressure 2 is unknown, right? And if we talk about the volume, so let's suppose initial volume is V1 and V2 is equals to double, twice of V1. Okay. So these are the values. So now if we substitute in the equation, so P1 is equals to 120 kilo multiplied by V1. P2 is unknown. V2 is equals to twice of V1. So you can see V1 will be cancelled out, and now you only left out with P2, that is equals to divided by 2. So that will be equals to,
60,000.
yes, or 6 exponent 4
Kilopascals.
pascals, right? So it is also,
Wait, isn't it kilopascals?
Uh, if you want to write in kilopascals,
Oh, wait,
so
no, no, no. Never
that
mind, never mind. Yeah, correct, correct.
yes, you can also write this one as 60 kilopascals.
All right.
So this is the question related to the thermal. And secondly, we have question number 4, and it shows a bottle part filled with water. The air inside the bottle is at the same pressure as the air outside the bottle. So basically the pressure of the air inside is equals to the outside bottle, and its contents are at room temperature. So the temperature of the bottle and its contents are increased. So now the temperature increased. And in the first part, explain in terms of molecules how the air pressure inside the bottle changes as the temperature increases. So initially temperature constant tha, but after that the temperature of the bottle and its contents are increased. Then you have to explain in the terms of the particles that how the air pressure inside the bottle changes. So we increase the temperature, and now they are asking about pressure. So again, you know what happens when we increase the temperature. So this is also the same question, right? Just like the previous one. So this type of concept is like most repeated in thermal section. So you will find many questions like the same in terms of particles, in terms of molecules, explain how pressure increase, how temperature increase. So this is also like the same part as we already discussed in the previous question, right? That it will increase. Increasing the temperature will definitely increase the kinetic energy, right? And what happens next? Frequently collisions. You can also copy paste the same answer from the previous one. Yes. The air particles gain kinetic energy, which results in term colliding with the walls frequently. As the result, pressure in the bottle increases, right? So I'm writing some key terms like frequent collision, average kinetic energy increases, forceful collisions with wall and molecules, change in momentum. So after all this change, pressure increases. Next we have the lid is removed from the bottle. So now we have open area over it. State and explain how the air pressure inside the bottle changes. So initially you can see it is completely covered with the lid, but when we remove the lid, so definitely molecules have now open atmosphere to leave from the bottle, and definitely it will change the temperature, it will change the pressure inside the bottle. So definitely pressure decreases because now it is open. And in explanation, we can say air particles escape from the bottle. Yes. And now the outside pressure is again equals to the inside pressure. Okay, next part. The mass of water in the bottle is 0.18 kg. So mass is given. Specific heat capacity of water is 4200 joules per kg per degree Celsius. Calculate the thermal energy. It means the amount of energy we have to calculate to increase the temperature by 20 degrees Celsius of water. So it is very simple. Mass is given. Specific heat capacity C is given. We need to calculate thermal energy and temperature is also given. 20 degrees Celsius. We know the formula C is equals to, and we have to find out the value of E. So E is equals to M into C into delta T. Mass is 0.18. Okay, 15,000. Right, we will check the answer also. 4200 multiplied by 20. Right. So we are getting answer, but round off it will be equals to 15,000 or 1.5 exponent 4 joules. We can also write that. Right. Okay. Last part of this question. Another plastic bottle is filled to the top with water. The height of the bottle is 40 centimeter and the density of water is 1 exponent 3 kg per meter cube. Calculate the pressure difference between the top and the bottom of the water. So now we have to calculate the pressure. So how to find out the pressure in this part? Height is given, density is given. So definitely this will give you the hint of the formula, that which formula is useful. Height into gravity into density, right? We have to use pressure in liquid. and we need to convert this centimeter into meter. 3920 pascals, right? 3920 will be equals to 39 pascals. Okay, question number two. A copper cooking pan contains water, shows the pan on a hot plate of a cooker. Copper is a metal and thermal energy is conducted through all solids by the lattice vibration. Describe one other way in which thermal energy is conducted through the copper. So the first method is mentioned that it can be conducted by the vibration of the particles. So they are asking about any other way in which you think that the thermal energy will be transferred through the copper. This is the whole scenario given in the diagram. Free or delocalized electrons gains heat energy and travel to the hotter and spread heat by colliding with atoms. Right. So in question, you can see there is already a hint given that copper is a metal. And in thermal energy section, we also discussed this idea that what happens actually that in metals there are free or like electrons are available. So free electrons also helps to transfer the thermal energy from one point to the other point or from the hot side to the cold side. So in this way, it helps to transfer the thermal energy with the atoms already colliding with each other. But with the help of free electrons, the rate of conduction will automatically increases. So right, this is the answer. Free electrons gains thermal energy from hot plate travel and transfer energy from hot end to the cold end along with the Particles or atoms of copper, and it also increases the rate of conduction. Okay, the next part, the outside surface of the cooking pan is kept clean by regular polishing. So outer surface is kept clean by regular polishing. Explain one other advantage of keeping the surface of the pan shiny. So why we are keeping the pan shiny or the surface of the pan shiny from the outside? And from this shiny word, definitely you will get the hint that what you have to write in this answer, because shiny surfaces are bad emitter of radiation. So shiny surface are the bad emitter of radiations. They are bad emitter, hence no heat is lost to the surrounding, right? So less thermal energy lost in the surrounding. And properties of shiny surface like black color is good absorber and emitter and bad reflector. Okay. Okay. Basically, when we are talking about black or dark color, so dark color is like good absorber and good emitter also, and bad reflector. So for shiny surface, it is like good reflector and bad absorber plus bad emitter. So all the things you are writing for the black, so that will be opposite for the shiny surface. Because you can see we write down a shiny surface are the bad emitter of radiation. So definitely they are also bad absorber and they are good reflector. So completely opposite to the dark color or the black color. The thermal energy passes into the water through the base of the pan. Identify the main method by which thermal energy is transferred throughout the water. So thermal energy is passing into the water with the help of the base of the pan. Identify the main method by which thermal energy is transferred throughout the water. So what is the name of the process through which the thermal energy is transferred? Convection, right? Because in water and in gases, we know convection process works, and convection only takes place in liquid and gases. Okay, so this is another question. Question number three, we have state which state of matter, solid, liquid, or gas, has the greatest thermal expansion and which has the least. So this is very easy. Greatest in gases, least is solid. Okay, because we know gases are already away from each other. So definitely they have greatest expansion, and solids are tightly packed, so their expansion is the least one. In part 2, describe in terms of the motion and the arrangement of the particles, the structures of solid and gases. In terms of the motion and arrangement about solid and gases. So we know that solid particles can vibrate only. So particles can vibrate. But if we compare with the gases, so particles move freely. Solids have particles close together, fixed upon their position, transfer energy through lattice. Okay. Solids are tightly packed and vibrate in their position, while gases are spread out and float around freely. Right. So you all know about the properties. So you may write down according to your. So particles move freely in the gases, the gases are in random motion. Next, we have define a specific heat capacity. So now you can see they are asking about specific heat capacity because these are like new pattern questions. So they are not asking about heat capacity only because previously they asked about it. So specific heat capacity is the thermal energy required to increase temperature of 1 kg of mass by 1 degree Celsius, right? So if we all know that definition is very simple, amount of heat required to raise the temperature of 1 kg or unit mass by 1 degree Celsius. Second part, a student carries out an experiment to determine the specific heat capacity of a metal. A cylinder of the metal is heated by 12-watt electrical heater. State the readings that the student takes. So basically, student carries out an experiment to find out a specific heat capacity. So definitely, one by one, it records the value, mass, change in temperature, and time. Okay. So definitely, initially when a student starts, so we are electrically heating up. So after some equal interval of time, like after 10 seconds, after every 30 seconds, or after every minute, we record the readings. So they are asking about to state the readings that the student takes. So definitely we take the readings for the time. We will take the readings for the mass of the water that is taken, or the mass of any liquid or the metal that is taken. And the third one, initial temperature, and definitely final temperature to find out the difference. So they are only asking about state, so you don't need to explain it. Just write down the names. So that will be the answer. Is change in temperature gonna be marked? Basically, they are asking about the readings, right? So you need to exactly mention initial and final. Then actually the change is the working, right? It is the calculation part. So that is not the reading part. So it is better to write initial and final. Okay, question number 5. We are using an electric heater to heat a room, and the dimensions of the room are this. Density is also given, and show that the mass of the air in the room is 79 kg. So mass is given, density is given, and these are the dimensions. So it means we can make up easily the volume from it. So now they are asking about the mass. So definitely we have to use the formula of density, right? Mass is equals to density into volume. So density is equals to 1.2 multiplied by 4.5 into 6.1 into 2.4. Okay, so after the multiplication, or 65.88 is volume. Okay, 79, right? So you are getting 79 kg. So you can see mass is already given. So you have to prove that your mass is equals to 79. Simple. And in the next part, the power of the heater is 1100 watt. Specific heat capacity is 1000 joules per kg per degree Celsius. Calculate the time taken to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. Power is given, specific heat capacity is given, time taken is not given. to increase the temperature from 16 to 20 degree. It means the change in temperature is 4 degrees Celsius. So now you have to find out the time. So actually the concept of power is given, right? And we know that power is equals to rate of change of work done or rate of change of energy. So from that idea, we can calculate the power. So power is actually equals to energy over time or work done over time. And in your question, you can see energy is not given. So first of all, we have to uh, find out energy, that is 316,000 energy. Okay. So first of all, we have to find out this energy. 79 is the mass. C is 1000 and delta T is 4 degrees Celsius. Joules. Now we can find out the value of the time easily because time is now equals to energy over power. Energy is divided by 1100. Okay, so you are getting, yes. So we need to divide these two quantities to find out the value of time. So 316,000 divided by 1100, that is equals to 287. Round off 290 seconds. Okay, so mostly in this section you will find easy questions as compared to the journal physics. In journal physics, questions are lengthy and slightly typical as compared to the thermal, because in thermal, syllabus is already very much reduced and questions are also very straightforward. And you can see you are getting 4 mark for this calculation. That is uh, very easy. 4 plus 2, 6 marks for this question. Then we have another question. The temperature of a fixed mass of gas at constant volume is decreased. State and explain in terms of the particles how the pressure of the gas changes. Again, you can see it is the repeated idea. Again, repeated question for 3 marks. So, most of the time they are asking about the same repeated question. So this is the most repeated question actually in the thermal section. And the next part is state the value of the absolute zero. We already discussed in the first question, that is minus 273, right? And explain what is meant by the term absolute zero. So we also discussed in the first question, refer to the particles in your answer. When the particles have the least kinetic energy, right? Good. So basically we all know about it, that it is the temperature at which the particles have least kinetic energy. and the motion of the particle are almost freezed. And part C, we have cylinder 1 which contains volume of 350 centimeter cube at a pressure of 9 exponent 4. The gas is transferred to cylinder 2 and the pressure is increases to 1.6 exponent 5. Temperature remains constant and we have to find out the volume of cylinder 2. So you all know that which formula we have to use in this question.
E1 V1 is equal to
Yes.
P2 V2.
So this is also like a repeated idea in this section of thermal physics. So V1 is given, P2 is given, V2 is unknown. Yes, V1 is equals to P2 V2. P1 is 9 exponent 4 and V1 is 350 divided by P2 is 1.6 exponent 5. So after multiplication and division, 200 centimeter cube. Okay. So this is the answer. And again, you can see you are getting 3 mark for this very easy calculation as compared to the journal physics questions and their calculations. So if you got like a question from the thermal physics with like greater weightage in the marks, so definitely it will be easy for you and it is also like time saving, because in this type of question you can see we just solve this question in 1 or 2 minutes very easily, and we can score marks also very easily as compared to other section. So this is the easiest section we can say as compared to any other topic.
Sir, could you go back to A and B for 1 second, please? Thank you, sir.
Okay. Okay, I already shared one drive link in the group, so I will update this file over there. So if you want to check after, or you want to solve, or you want to check that which questions are left out from the latest one, so you may also download the file from that link. Okay, so again we have another question 4 from other paper. Okay, in this question, a student investigates the efficiency of a filament lamp. So we are talking about efficiency right now, and it shows the filament lamp with its glass bulb immersed in the water in a beaker, as we can uh, see in the diagram. And the reading we got in the thermometer is 19 degrees Celsius. On the glass of the lamp is in contact with the water. So only the glass of the lamp is in contact with water, and electrical connections are completely insulated. Okay. So there is no chance of like electrical transfer in water. So the lamp is switched on. At the end of the experiment, the temperature of the water is 21.5 degrees Celsius. The mass of the water in the beaker is 600 grams, and the specific heat capacity of the water is 4200 joules per kg per degree Celsius. And we have to calculate increase in internal energy of the water is 6300. So basically we have to show this. All the values are given. So at the end of the experiment, the temperature of the water is 21.5, and initially we started from 19 degrees Celsius. Value of C is given. Mass is also given, but in grams. And we have to show the internal energy, or the change in internal energy, is equals to 6300 joules. So again, we use the same formula. E is equals to M into C into delta T. So mass is 600 divided by 1000 multiplied by the value of C into the change in temperature. Okay, so after the multiplication, we are getting same value, 6300 joules energy, right? Okay, in the next part, the lamp is switched on for 500 seconds, so time is given. The power supplied to the filament lamp is 13 watt, power is given. The useful energy from the lamp is transferred as light, okay? And the energy that increases the temperature of the water is wasted energy, because the energy transferred to the water, that will increase the temperature of the water. So definitely that is the wasted energy, because we are not increasing the temperature of that water. So determine the maximum possible efficiency of the filament. Time is given, power is given, and the useful form of energy is in the form of light. So light is useful, but increasing the temperature of the water is the waste form of energy. So we only need to consider the useful form of energy. So in the first part, we calculated that 6300 joules is the amount of energy that we calculated in the first part. And now, if we calculate the energy from the second part, so energy is equals to power into time. So power is 13 and time is 500. So what is the amount of energy we are getting? 6500. So from 6500, we are only getting useful energy, which is 63. Sorry, wi- this is the amount of energy. You can see the mass of the water in the beaker is 600, and the specific heat increase in the internal energy of the water. So in the first part, it is clearly mentioned that we calculated the internal energy of the water. And in the second part, it is mentioned that the energy which is used to increase the temperature of the water is wasted. So actually, we calculated the wasted energy in the first part, right? So this is the wasted energy. And the 6500 is the total energy transferred And from this 6500, we only got 200 joules of energy as the useful energy. So the useful energy is only 200. So now we can calculate the efficiency. So we are getting 3.1%. So 3.1% is the efficiency of this whole setup. Because for the water energy is like the waste form of energy. That's why we have to identify. This is very important because you are getting 4 marks in this question. So definitely most of the student just do like 6300 over 6500. So that is actually the wasted energy. It is clearly mentioned in the question about the water. Question number 3, a rubber balloon is inflated with helium and sealed so that no helium escapes. The balloon is positioned immediately below the ceiling in a room, and heaters are switched on. The temperature of the air in the room increases. So we just turn on the heater, temperature starts to increases, and there is a helium which is positioned immediately below the ceiling in a room. Okay, when the heaters are first switched on, the temperature of the air immediately below the ceiling increases more quickly than the temperature of the air in the rest of the room. So explain why this happened. So why the temperature below the ceiling increases more quickly. As the air below the ceiling is dense, so hence heat is transferred quickly as particles are closer. Okay, right. So we know that in the convection we discussed that hot air will always rise to the top, and the cold air molecules moves in the downward direction. And definitely when cold molecules moves in downward direction, so it means that on the top or below the ceiling immediately, the particles are cold and they are very close to each other, and definitely they will transfer thermal energy very quickly to each other. So right, this is the right concept that we have to mention in this answer. क्योंकि जितने भी कोल्ड मॉलिक्यूल्स होंगे वो सबसे टॉप पर होंगे, very close to the ceiling, and when heater turned on, so they are close to each other, so वो fast energy transfer करेंगे as compared to the hot molecules. So cold air is, or cold air particles are more dense. Hot air particles. Basically, cold air actually falls and hot air rises because hot air is less dense, and less dense will always on the top, and the more dense will be at the bottom. right? Okay, basically in your answer, they are asking about the temperature of the air immediately below the ceiling increases more quickly because hot air molecules are moving in upward direction. So that's why, first of all, in your overall room, if you compare your all area of the room, so the area close to the ceiling will, the temperature of the area close to the ceiling will increase more quickly because hot air molecules are moving in upward direction. So definitely the top area of the room will be heated more as compared to any other space in your room. Okay. So hot air particles are less dense. So hot air molecules
The hot air molecules will rise up while the cold air molecules will go down, and then combustion will happen.
yes. So they starts to move towards the ceiling and cold air molecules falls and the temperature of air immediately below ceiling increases. Right? So this is the simple idea of the convection process you have to mention. In part B, the temperature of the helium in the balloon increases. So this time the temperature increases in the balloon. As the rubber stretches, the volume occupied by the helium also increases. So the volume of the balloon also increases. Right. State what happened to the motion of the helium particle as the temperature increases. So again, we got the same question, right? They are only asking about the particles, and we already answered this type of question in the previous different papers about the pressure increases. So this is also the same, but this time they are only asking about 1 mark because they mention state. But this is again this repeated idea. So the particles of helium gain kinetic energy, move faster, right? So you don't need to write very much detail because this time they are only asking about state what happens to the motion of the helium particles. So basically, motion of the helium particles will be faster because their speed will increase because their temperature increases. Speed of the particles of helium increases. Simple. And as the rubber stretches and the volume of the helium increases, the pressure of the helium remains constant. Okay, so this time pressure is constant. Explain in terms of molecules. of helium, how the pressure of the helium remains constant. So this time you have to explain how the pressure remains constant. Due to increase in temperature, the particles gain kinetic energy and increase pressure. But as volume has increased and therefore the area increases, hence pressure decreases. So both the changes cancel out each other effects. Okay. So basically what is happening in the previous questions, we got fixed volume, but this time volume is not fixed. Volume is like increasing. So volume is also increasing and pressure of the helium remains constant. So basically, in the first part, we discussed that the temperature of the helium increases. So temperature and volume is directly proportional, right? So when temperature increase, volume increases and molecules get enough space for their vibration. So that's why the pressure is not increasing. Yes. So definitely they got more area, they got like more space to vibrate. So they can easily vibrate in the given space. So that's why the pressure is not increasing because volume is not fixed. So they have actually, so due to increase in volume, they are getting larger space to vibrate. And due to this, less frequent collision or the frequency of collision will decrease. And as you mentioned, larger surface area. And when we have large surface area or when we have large volume, so this will cancel out the effect of increased temperature. So definitely pressure will again come to its original value. And your answers are also right that you mentioned in the chat. So there are different ways to phrase the answer, but the points you mentioned are also right. Okay, so this is another question. Okay, now we have some old papers that is from 22. So maybe you will get some questions or some parts of the questions that are not the part of our syllabus. So we also need to check that one. Let's see. So from question 5, we have three identical dishes A, B, and C. Identical means completely same size, same volume, all the things are same. An equal volume of water is filled. Dish A is outside in sunlight and experiences no wind during the day. And if we talk about dish B, so B is outside in sunlight and experiences a strong wind during the day. And if we talk about the C, so C is in a dark room. So we have three different dishes in three different conditions. Water evaporates from each dish. After 12 hours, a student measures the volume of the water in each dish, and dish C contains the largest volume and B contains the smallest volume of the water. Explain in terms of the particle why the three dishes have different volumes of water. So I think it is also simple to answer because you know that all the conditions are very much clear. Because we know that if we talk about dish A, so dish A is outside in sunlight. Okay. So it is getting thermal energy. So temperature increases, rate of evaporation also increases, and dish B is also in sunlight. So B is also getting high temperature plus strong wind. So B has like two factors that will increase the rate of evaporation. But dish C is in a dark room. So basically C is in a dark room, and dark color, you know that is a bad reflector, good absorber, good emitter. But definitely it is in a dark room, not in the sunlight. So definitely evaporation will be affected because of the dark room. So we will explain like first of all for C, because C is in a dark room. So the rate of evaporation decreases. Okay, has least evaporation as the molecule have no energy to evaporate and volume remains the same. Okay, good. And B has the greatest evaporation as the water particles gains thermal energy and highly energetic molecules evaporate. And right, dish A has a little evaporation and a small change in volume as the particle. Okay, so I got this answer and I am copy pasting this answer also. So basically, you know that factors are very much clear in your question. So it is not very difficult to write the answer. One by one, you just start from either from dish A, dish B, or C. It's up to you. You can write down from any reference. So you can explain according to your choice. You can see dish C, B, and A. So we also start from C because there is no evaporation like significance evaporation takes place in C. But in B, B has like two factors to increase the rate of evaporation. So that's why the evaporation for B is the greatest one. And A is like the normal as compared to B and C. Now we have question B, latent heat of vaporization. This topic is not included. So again, I mentioned that this is from the previous 22 year. That's why you got this question. So just skip this part because I maximum try to just remove the questions of the old syllabus, but some parts are there. So I just keep these questions for these parts. Okay, so let's see the last part. We have a part C with figure 5.1 and it shows an insulating beaker, crushed ice, and immersion heater and a thermometer. Okay, so these are the components we have in this diagram. Now the initial temperature of the ice is minus 60 degrees Celsius. The immersion heater is switched on and the temperature is recorded at equal intervals of time. So after every equal interval of time, you will get this graphical representation. And we have A, B, C, D marking on the graph. And you have to describe what occurs in each of the sections A, B, C, and D. So what do you think what happens in the part A? So definitely temperature is increasing, right? So in part A, we have increasing
Wait, so can you show the question?
temperature. We started from minus 60 and continuously temperature is increasing.
Ah, okay.
Okay. So initially, we have some gradient of the graph. So definitely the temperature is increasing. And at B, so at B we have horizontal line. It means at constant temperature. And when we have constant temperature, so it means there is a change of state takes place. So there is a change of state from solid to liquid. So ice is actually melting and converting into the liquid.
At section B, the ice will melt and turn into water.
Yes. And again, we have a gradient in the graph C. So the temperature increases for liquid. And in final part D, we again got this horizontal line. It means uh, now liquid is converting into the gaseous state or into the steam.
Yes, the liquid will boil,
Yes.
boil to become vapor.
So liquid is boiling.
It will become a water vapor.
Yes. So we already discussed this graph in the theory during the class lectures also, because we know that this is like a fixed questions that is asked in the exams. Okay, so only one part of this question is not included. We remove that part from. Okay, we have another question from the thermal. It shows an aluminium block after leaving a furnace in a factory. So we have aluminium block in this question. Next, the mass of the block is 1200 kg and it is heated from in the furnace from 20 to 380 degrees Celsius. The aluminium block does not melt. Specific heat capacity is given. Calculate the thermal energy gained by the block in the furnace. Again, mass is given, change in temperature is given, and aluminium block does not melt, so there is no change of state. Value of C is given. We have to calculate the thermal energy gained by the block, amount of energy. So energy is equals to M into C into delta T, 1200 multiply by 960 multiply by 360, that is the change in temperature. So you will get answer something like 414720. So we just rounded off to 41000, or yes, 4.1 exponent 8 joules. Okay. And figure 5.1 shows a factory worker is standing 3 meters from the block. State and explain the main process by which the thermal energy is transferred to the worker. So in the diagram, you can see this is the factory worker which is standing almost at a 3 meter distance. And they are asking about the main process through which the thermal energy is transferred to the worker. So you can see this is the aluminium block. So aluminium block is at a distance of 3 meters. So that is like a good distance. So definitely it is not conduction. It is not convection. It is radiation. Because in convection, if you write, so convection will transfer thermal energy into the upward direction. And for conduction, you require a direct contact between the worker and the block. So it is radiation. So again, there is aluminium. Aluminium is a metal, so there are free electrons. So there are free electrons. In an aluminium, and thermal energy. And definitely we know that radiations do not require any medium to travel. So radiations can easily travel in normal atmosphere or in vacuum also. So definitely when free electrons collide, so they transfer energy to the neighboring particles. And definitely they collide with the particles of the air also and transfer energy very easily. Because if we talk about air or if we write down for the air, so convection takes place in the air and that will move in the upward direction. And when we provide very high temperatures, so the free electrons or the particles of the aluminium transfer energy with the help of the vibration and transferring energy to the neighboring particles in the form of radiation towards the worker, right? And collides with the neighboring particles. To transfer energy to the worker. Basically, in this question, according to the marking scheme of this paper, there is no specific, basically for this question in this year, right? It is also good to write that infrared radiations can transfer. So that will give you maybe 1 mark for it. But in this paper, they only give you 3 marks, one for writing the term radiation, and also you can mention any type of radiation like infrared or electromagnetic waves, and also it is absorbed by the workers, so you can explain in that concept. If you want, you can also write the concept of uh, the name of the infrared, right? That thermal energy transferred through infrared radiations or electromagnetic radiations, right? And state and explain the main process by which the thermal energy is transferred from the outer surface of the solid metal rollers to their interior. So again, you have to mention the main process of the thermal energy transferred from the outer surface of the solid metal rollers to the interiors. So in this process, definitely it is conduction, because now they are talking about the solid metal rollers to their interior. So when we are talking about this solid metal rollers, so definitely they are in contact with each other. So with the help of conduction, heat can be transferred. So in conduction process, again, the same idea of electrons, that electrons, free electrons, and the particles can transfer thermal energy from the hot end to the cold end. Actually, I mistakenly mentioned all the points in the first one for the both part. And you can continue your answer. You know that they collide with the neighboring particles also, and they can easily transfer energy in the form of conduction. Okay, this question is also the same. Only part A is like different from the other the questions that we got till now. Explain in terms of the momentum of the particles, how a gas exerts a pressure. But in our notes, if you check, you will get how we explain this idea. Let me show you because I have that one also. Okay, but if you will not check from the notes, you will also know that how to mention that how the temperature or how the pressure of the gases actually increases. Because the next part is the same as we already discussed in the other questions. Okay, I will write down again over here because we know that they are asking about the momentum of the particle, how a gas exerts a pressure. So we know we start from the same idea that when particle starts to move, so they have momentum because momentum is mass into velocity. And they also hits the wall of container and neighboring particle. And you know that yesterday we are talking about the question related to the momentum, the collision of the objects, like one object is colliding with the other. So when one object collide with the other, so definitely after collision, the direction changes, so momentum automatically changes. So after collision, change in momentum takes place. because of collision. So now we mentioned that how the momentum changes. It is because of change in momentum. And when change in momentum takes place, so definitely there will be change in force, because we know force is also defined as the rate of change of momentum. So due to change in momentum, exerted force on the wall changes or increases per unit area. Hence, pressure increased. So, first of all, you just need to mention how the momentum changes. Momentum changes because of the collision, and when momentum change, so there is definition of force. Rate of change of momentum is called force, and when force changes, so definitely, when it collides with the wall, so force per unit area also changes, and that results in the concept of the pressure increases on the wall, or the general formula or the general concept about the gases that exerts the pressure. And the next part is again the repeated one, that how the change in pressure of the gas takes place at constant volume. So this is again repeated part. And this is also simple. We know that we have to use a new pressure. We have to calculate new pressure. P1, P2, P1 V1 is equals to P2 V2. So this is again the same formula we have to use in this part. So this question is also the same. Okay, this is a lengthy question. Okay, so this is a very lengthy question as we observed. So let's see what is the question. So a quantity of a gas is trapped by a piston in a cylinder, and thin metal balls. We have the piston is free to move without friction within the cylinder. Cylinder is placed inside a freezer. The air in the freezer is at atmospheric pressure. So atmospheric pressure is given. The area of the piston in contact with the air in the freezer is, so area of the piston is also given. So we have pressure, we have area. So calculate the force exerted on the piston by the air in the freezer. So first part is very simple. By using the formula of pressure, or area is equals to, sorry, we have to find out the force, pressure into area. So pressure is equals to atmospheric pressure. Area is given 2.4 exponent minus 3. So you just need to multiply and you will get the answer for the force, 240 Newton, right? And in the next part, when the cylinder is first placed into the freezer, the temperature of the gas in the cylinder decreases and the air pushes the piston into the cylinder. So what happens actually? The temperature of the gas cylinder decreases. So in the second part, temperature decreases and the air pushes the piston into the cylinder. So this piston starts to push inside in the second part. Calculate the work done on the piston by the air in the freezer. Definitely the air outside the piston starts to push that piston into the uh, inside, and the distance covered is 0.021 meter into the cylinder, and we have to find out the work done on the piston. So the formula for the work done is F into D. So we already calculated the force. The work done is equals to F into D, very simple. Force is 240, distance is 0.021 meter. So when we multiply 240 into 0.021, 5.04, so round of 5 joules. And in part B, the initial temperature of the cylinder and the gas is 21 degrees Celsius. So we have initial temperature 21 degrees Celsius in the freezer, and the temperature of the cylinder decreases to minus 18 degrees Celsius. The thermal capacity of the cylinder is 89. Calculate the change in internal energy. So again, we have to use the same idea. Mass is equals to, okay, in this, you can see they are asking about thermal capacity. So in thermal capacity, what we have to do, there is no need of the mass, because there is only the value of thermal capacity is given, and this thermal capacity is now excluded from our syllabus. If a specific heat capacity is given, so then we can use the formula of a specific heat capacity, but this is not a specific heat capacity. So in this formula, you don't require the mass, so you can calculate without the mass. So that's why this part is also excluded. So just skip this part. Okay, let's solve any other question. Energy, calculate the mass. Okay, this part is also simple. Same specific heat capacity. Okay, this question 4, part A. Okay, so it shows apparatus used to observe the motion of the smoke particles, that is the Brownian motion. And the glass cell has light shining on it from the outside. The smoke particles are seen as bright specks of the light when looking through the microscope, and draw the path of one of the bright specks of the light. So you have to draw the path of one of the bright specks of the light. So we know that in Brownian motion, you have like a zigzag motion. So you may draw any zigzag pattern, any irregular pattern, or the random uh, change in direction pattern, okay, to show the motion of that bright specks of the light. And in the second part, explain in terms of the forces and the motion of the air particles, the cause of the motion of the smoke particles. So basically, in terms of the forces, we have to explain the motion of air molecules that causes the motion of the smoke particles. Okay, so basically we have smoke particles and air molecules. So we have two different particles. So basically, the air molecules starts to bombard it. The smoke particles, and smoke particles are like greater in size as compared to the air molecules. So they are greater in size as compared to air molecules, and air molecules have a small mass. So when air molecules have a small mass, they can move in random direction with faster speed, exerting unbalanced force on the smoke particles. So this is the concept of the forces and the motion of air molecules. Next, we have part B. The temperature of the air in a sealed gas container is increased. So we have sealed gas container and the temperature increases. Explain in terms of the molecules why the internal energy of the air increases. So basically, due to increase in the temperature, kinetic energy increases. So that's why we can say increase in temperature also increases. The kinetic energy of the particles. So in short, the internal energy increases. In the next part, explain in terms of the molecule why the pressure of the air also increases. Again, the same idea. We have sealed container. Sealed container means volume is same. So again, when the volume is same, the kinetic energy increases, and due to change in kinetic energy increase, there will be uh, change in the momentum. So due to high kinetic energy, momentum changes, and when the momentum changes, molecules collide. More frequently with the wall, exerting the force per unit area. So that will also increases the pressure of the air. So mostly in thermal, we are getting same idea about the pressure, volume, temperature, because now thermometer is not there, latent heat is not there. So definitely we have very limited idea and very limited concepts left out. So that's why we are getting again and again same idea, same concepts in the thermal. Okay, this is a liquid glass thermometer. This is also excluded. By mistakenly, it is like left in this file. You can see again, it is related to the boiling point. So you may skip this part also.
Is it not a part of the new syllabus?
Yes. Actually,
Oh,
while
okay, sir.
sorting out the questions, you know that I just try to find out from the initial statements. So maybe some parts I just missed during the file making. So that's why most you will sometimes you will get some questions like this that are no more included. Like again, you got thermocouple over here. So thermal couple is also not the part. Okay, you may skip this part also. I will send this file so you may also check that which question is actually cut out. This is from May June 22, paper 4, variant 1. This question is related to evaporation. And in this question, they are asking about during a picnic on a warm day, a warm, dry day, a metal can of lemonade is wrapped in a damp cloth. Evaporation cools the water in the cloth. Explain in terms of the molecules how evaporation cools the water in the cloth. So how evaporation cools the water in the cloth? So basically in this, we know that the high energetic molecules, high energetic molecules leaves the surface after getting. So basically, if the temperature of the cane, because cane is a metal, so if the temperature of the cane is higher, so the we have damp cloth. So that is already consisting of so many water molecules. So that water molecules from the cane gains that energy and it starts to evaporate. So high energetic molecules leave the surface after absorbing thermal energy. And definitely when high energetic molecules starts to leave, so this process is called evaporation. And they are going to add up into the air, decreasing the temperature of the surface. So in this way, uh, the evaporation actually cools the water in the cloth. And as the water in the cloth cools, so does the laminate. So after the decrease in the temperature of the water or the cloth, the laminate also cools down. So explain how electrons transfer thermal energy through the metal of the cane. Because cane is metal, so now they are asking about in the terms of electron, that how electrons transfer thermal energy through the metal of the cane. So again, you have to mention the same idea that there are free electrons. So free electrons also gains energy and transfer. And are transferred through vibration and collision with neighboring atoms and electrons. and transfer through the metal to a long distance. So this is the process for the metal, for the free electrons in the metal. Because we know idea is the same. We know how free electrons reacts when they get thermal energy and how they transfer their thermal energy when they absorbs energy from somewhere. So mostly we observe that the questions are like very much similar in the previous years also, because again due to the syllabus change, many topics from the previous topics, many topics from the previous syllabus, from the old syllabus are excluded, and still we are getting many questions after sorting out or after deleting many questions. We are still getting many questions from the excluded topics. Like this thermal capacity is no more included, but the next part is included. So that's why I just leave some questions in this file so that we can practice those concepts only which are included, and we skip those parts which are not included. Like this, the first part is not included, latent heat of fusion, but you can see B part 1, it is related to evaporation. So this part is included and the next part is also included. So in this way, in most of the question, you will find that half of the questions are the part of the syllabus, half of the question is not. So you may just skip those questions, like half questions, like this. And in part B, you can see that a cup of water contains 250 centimeter cube of water at temperature 0 degree. And we have same identical cup contains 250 centimeter cube of a mixture of ice and water at 0 degree Celsius. And the surrounding temperature is given, explain, and state what happens in 10 minutes. So you can see this question is fine because this is the part of the new syllabus. So you can solve this question.